We're going to start this section, my friends, with a confessional. And not a video confessional like reality TV shows have. We're going to have an honor confessional because we can't see each other. Raise your hand if you thought you learned almost everything there is to know about EIGRP during your CCNA studies. And I'm raising my hand too. We're both wrong, but it's easy to think, hey, EIGRP, you got your neighbor relationships, that's pretty much it. You got your neighbor command and you're done. Well, there's a lot more to EIGRP than what we both learned during our NA studies. And you might have gotten your CCNA 2 weeks ago. You might have gotten it 2 years ago. I don't want to make the assumption that these fundamentals are fresh in your head because I don't care how bright you are. If you don't look at something for a couple of years, you get rusty with it. Got a little bit of new info in here for you if you just took the exam a couple of weeks ago too, if it's still fresh in your head. But I do want us to go over the fundamentals before we go into new territory. Now, EIGRP, the E comes from this being the enhanced version of the long gone, not missed at all, dumb as a sack of rocks, Interior Gateway Routing Protocol, IGRP. I do not mean to be disrespectful because at the time we were glad to have it, but IGRP, no longer supported by CISCO, is not on the exams, and you're not going to see a mention of it anymore in the iOS. Previous iOS versions, even if when you used if you were on a router that IGRP was not working on because it's been obsolete for quite a while, and you would use iOS help to look at an EIGRP value, and occasionally it would refer to IGRP. And of course, if you're new to this, that would really throw you. And I got tweets, emails, Facebook messages every week, hey, I'm using this in a lab, and it's mentioning IGRP. Well, as you'll see when we do plenty of live labs here on live Cisco routers, as always, you're going to see that those mentions of IGRP are gone, and it only mentions EIGRP. Now, officially, EIGRP is known as a hybrid protocol. It has characteristics of linked state protocols and distance vector protocols. And as you'll see, EIGRP acts much more like a linked state protocol than a distance vector protocol. The main distance vector protocol, behavior, that is this initial exchange of full routing tables between EIGRP neighbors. And the key word there is initial. Because what drove us crazy about distance vector protocols, if you've worked with them before? Because RIP version 1 and 2, they're still around, they're just not on this particular exam. One thing that drove us crazy about them were those regular transmissions of full routing tables. And unless you were working on a really unstable network, you just didn't need the updates as often as RIP gives them to you. And again, they're full updates every single time. Well, the only time that EIGRP routers exchange full routing tables is when they are newly adjacent. That's it. And after that initial exchange of full tables, an EIGRP router is going to send an update only when there's a change in the network. And on top of that, that update will reflect only the change, and it's not going to consist of a full routing table. Now, a couple of other benefits EIGRP brings us are rapid convergence, and we'll take all of that we can get. And the reason that EIGRP brings us such rapid convergence is that the backup routes, called feasible successors, they're actually calculated before they're needed. That's pretty cool, and they're kept in a separate EIGRP table, and if they are suddenly needed, if the primary route, the successor, disappears, then that feasible successor is quickly promoted to successor, no route calculation needed because they've already been calculated. We love that, and we'll see that in action. Multi-protocol support including IP, IPX, and AppleTalk, and support for VLSM and CIDR. Now, those benefits, though, can't really benefit us until we get the adjacencies up and running, and that's why I want to go over the fundamentals with you here for a few minutes, because ain't nothing happening between our EIGRP speaking routers until we get that adjacency formed. Now, how does that happen? EIGRP uses hello packets. They're multicast to 224.0010 to both establish and maintain neighbor relationships. And it's the Reliable Transport Protocol, RTP, that is used to handle the actual transport of messages between EIGRP-enabled routers. Now, EIGRP uses a logical grouping just like OSPF does, but we're not using areas with EIGRP. We're using something called an autonomous system. Sounds complicated, but it's really not. The AS number simply identifies routers that belong to the same logical group. And EIGRP speakers that are in separate ASs, they cannot become neighbors. That's the first thing you ought to look at, whether it's in a lab, a job interview, exam question. If you have an adjacency issue, check the AS numbers first, right at the top. Router EIGRP 100, router EIGRP 200, no use in even looking at the config. That is the problem. Now, once the adjacency is formed, it's kept alive by a steady flow of hello packets from the neighbor. Almost everything we deal with like this in Cisco, from frame relay to EIGRP, it's got some kind of heartbeat. It's got some kind of keep alive. And with EIGRP, that's the EIGRP hello. If those hellos stop coming, as we'll see, the adjacency is going to eventually be dropped. Right now, before we get to our first live lab, let's spend a little more time with the successor and feasible successor. I'm going to bring that router number up. Now, EIGRP keeps 3 very important tables. Got to know these, and you got to know what's in each one. The route table, of course, stores the best route to any known destination, each remote network that the router knows of. The topology table keeps all our known, valid, loop-free routes to those same networks. That's where you'll find our successors and our feasible successors. And then finally, the neighbor table. Hate to insult you by even telling you what's in there. It's info, of course, on the router's EIGRP neighbors. Now, when it comes to that rapid convergence, that rapid recovery from a lost route, that's where the route and topology tables both come in. And here's a non-detailed example. We'll be seeing a lot more details in this, but this is just a walkthrough. Here, router 1 has 2 paths to router 4. It can go through router 2 or it can go through router 3. Now, EIGRP has somehow determined the path through router 2 is the best path. So that route is going to be put into the route and topology tables. That's our successor route, the best route to R4. Now, EIGRP has also determined the route through router 3 is valid. It's free of routing loops as far as EIGRP can tell. So that makes this route a feasible successor. It's a valid loop-free route whose metric is not quite as good as the best route. That's a feasible successor. Feasible successors are put into the topology table only. Now, should that primary route suddenly be lost, this is the best part of EIGRP, really. It doesn't need to calculate a new route. It doesn't need to go, I don't have this route. What am I going to do? I got to come up with a calculation. No, it just looks in the topology table, says, hey, there's my feasible successor. There's my backup route for that destination. I'll make it a successor, puts it in the routing table, and routing goes right on. And that's exactly what happened right there. Our path through router 2 became unavailable. Router 1 looks in its topology table, says, hey, I've got a feasible successor for the network on R4, and the next hop is this R3 guy. I'll go that way. Now, we're going to see the successor and feasible successor in action with slightly more details on live routers throughout the next couple of labs, but the key is it really works like that. It really is that simple. The EIGRP metrics get a little long. We're not talking onesies and twosies here. We're talking 7-digit, 8-digit, 9-digit numbers. But just keep in mind, this is the way the successor and feasible successors work. We are going to jump into our first lab right now. And we're going to configure EIGRP adjacencies on this network. Should look familiar to some of you. It's a hub and spoke network with router 1 serving as our hub. 2 and 3 are going to be the spokes. So any spoke-to-spoke traffic must go through the hub. Each router's serial 0/1/0 interface is connected to the frame relay network. I will test that before the lab off screen, and I will send pings around. You always do that before you start a lab. We're going to use the 172.12.123.0/24 subnet for our addresses, and as always, the router numbers are going to be used for the 4th octet of the address. And we're going to add some loopbacks, but we're going to do that a little bit later. We're at the 10-minute mark of this video, so at the beginning of the next one, we will jump straight into this lab. I'll see you there.